Okay, so you should have printed the worksheet to go along with these notes. And what we're going to add today is our trigonometric. And when I say our trigonometric, what I'm talking about here are the following. We know that the sine of x, with the integral of the sine of x with respect to x, is a negative cosine of x. So the u substitution rule that goes with that is that the sine of u times u prime is equal to the negative cosine of u plus c. We've got a u substitution rule for cosine, for secant squared, for cosecant squared, for secant tangent, and for cosecant cotangent. Last time we were here, we looked at the power rule. So up to now, these are the only rules that we've looked at. We're going to continue to use this sheet as we go. Notice the process on this is that you always start by looking to see if you can fit a basic rule. Basic rules are being the ones on this side. And then from there, if you can't, you'll go for the u substitution. Remember, you're going to need a u and a u prime. It's real important that as we're going through this that you do not try to pick out your u and your u prime ahead of time. We're going to look at what choices we have for you as we go through some examples here. Let's go through some examples, and do know that we're going to combine everything when we do this. So we will have some of the regular basic rules mixed in here. That's why the process is becoming more and more important to us. So go ahead and do some examples here. For example 1, I want to look at the integral of the cosine of 5x plus 1 with respect to x. And so if I go through my process, the first thing I do is try to fit a basic rule. And the only basic rule that I have for cosine is exactly cosine of x, which this is not. So we're going to try for a u substitution. We can let u be the bigger piece, the piece that's being raised to a power. We can let it be the angle in a trigonometric function, or we can let it be the entire trigonometric function. The important thing here is that whatever we pick for u, that we can either get or already have the u prime that goes with it. In this case, we might let u be the angle, which is going to be 5x plus 1. If that's u, then the u prime that goes with that is a 5. And the thing with numbers is we can always get our numbers in here. Let me show you how that works. Based on the way I've defined u, I can see that this part represents the cosine of u. And remember, even though we need the u prime, it won't come out of the answer, but we've got to have it there. So I need a 5, and again, I can get those numbers as long as I multiply on the outside by a 1/5. Anything on the outside is going to carry down. And when I integrate, and I'm looking at the stuff in blue right here, when I integrate u prime times the cosine of u, what I get back then is the sine of u plus c. So putting in our u, that's going to give me the sine of 5x plus 1 all plus c. Let's try another one here. Let's look at the integral of the secant 3x tangent 3x with respect to x. And it's absolutely essential as you're going through this, folks, that you do indeed know your basic rules. We have a basic rule for secant tangent, but it has to be an exact x, a secant x, tangent x, and we don't have that here. So we're going to attempt a u substitution. I might consider letting the u be equal to 3x, that is the angle. If that's the u, then the u prime that's going to go with that is a 3. And when I look at what choice I made there, here again, I have the secant of u times the tangent of u. Remember, we're going to need that u prime. In this case, the u prime we need is 3. So we'll multiply on the outside by the 1/3. The u prime never comes out in the answer, although we do need it. Anything on the outside, however, does come down to the answer. So the 1/3 comes down, and when I integrate the secant of u, tangent of u, I simply get back the secant of u plus c, and then so putting in our u, this is going to give us a 1/3 times the secant of 3x, all plus c. Okay, so for our next example here, I'm going to do two that kind of look very similar, and let's look at the difference in them here. And I'm going to do a versus. I really don't have a lot of room on this screen, but I'll try to do them side by side. So this is going to be, let me get the right pen here. This is going to be our example number 3. Okay, so here I want to look at the sine of 3x times the cosine squared of 3x with respect to x versus the integral of the sine of 3x cosine of 3x with respect to x. And then let's go through each of the parts here. Starting with the one on the left, what I can see here is that I don't have a basic rule. None of my basic rules actually have a sine and a cosine in them. So I'm going to go for u substitution. Now, if I just allow u to be the angle, then I run into the same problem. I'm going to have a sine of u and a cosine squared of u, and that's not anything that I can do anything with. So what I might try instead, remember there's lots of choices. We can let it be the bigger piece, the piece that's being raised to a power. We can let it be an angle, or we can let it be an entire function. If I'm going to let it be the entire function in this case, I'm going to pick the thing that's being raised to a power. So for this one, I'm going to let u be equal to the cosine of 3x. Now, if that's u, the u prime that goes with that is going to be the negative sine of 3x times that derivative of what's inside. So we actually get a negative 3 sine of 3x. So looking back over here, this is going to give me my u squared. This is almost my u prime. I am simply going to need a negative 3. So I will multiply on the outside by its reciprocal, which is a negative 1/3. Remember that anything on the outside carries down. And look at what I put in blue here, because this is what becomes important. And when I say don't pick it ahead of time, I am not actually integrating using a sine or cosine at this point. I am integrating using a u squared times a u prime. And when I integrate u squared times a u prime, I get 1/3 u cubed plus c. And so then I can just combine those things in the front. Negative 1/3 times 1/3 is going to give me a 1/9, and put back in my u. So I get 1/9 the cosine cubed of 3x plus c. That's one of the reasons that you will always see me put that u and that u prime, the u's and the u primes underneath, so that you can actually see what it is you are integrating. Now I'm going to take my verses and I am going to come down here, because on this one I am also going to do a u substitution, because it's definitely not a basic rule. Notice here that neither one of these pieces is being raised to a power. However, regardless of which of the two I choose, for my u, I will have a u prime that goes with it. So let me write this here a couple times and we'll look at what I mean by that. Okay, we're going to do it twice because I do have an option here. I'm sorry about that color on there. My color chart is kind of standing in my way here. Okay. So what are my choices for u in this? Well, I do have something that's being raised to a power, and I do have a choice of what I pick for u. In other words, I could pick u to be equal to the sine of 3x. If I let that be my u, well, this is just then a u to the first power. It's not a big deal. It's still a u. And the u prime that goes along with that is the cosine of 3x times the derivative of what's inside, which is 3 cosine of 3x. So when I look at this, then this part becomes the u prime almost. I'm going to need a 3 in there. Let me see if I can squeeze it in there. So I'm going to need to multiply on the outside by 1/3. Now remember, we need those u primes on the inside. They don't come out in the answer. However, anything on the outside of this thing does. So this 1/3 carries down. And again, see what I wrote in blue? That is what I am integrating. So I am integrating u to the first times u prime, which is going to give me a 1/2 u squared plus c. And so combining that all together and putting back in my u, this is going to give me a 1/6 times my u, which was the sine of 3x squared. And of course, you do know that we'd put those squares up here in between the number and the function. Now, let's go ahead and look at the other option that I had on this, and I did mention it. It doesn't really matter which one you pick for u, because I will have the u prime no matter what. I could have just as easily let u be equal to the cosine of 3x, just like we did in the other part of our example up top. If I were to do that, then of course the u prime is going to be, again, a negative 3 sine of 3x. Derivative of cosine of u is the sine of that u times u prime. So now this actually becomes my u to the first, and I almost have my u prime here. Once again, the only thing I need is, in this case, a negative 3. So I'm going to multiply on the outside by the negative 1/3. Again, we need that u prime in there, though it does not come out in the answer. The negative 1/3 is going to carry down because it's on the outside, and when I integrate u to the first times u prime, I'm going to get, again, another 1/2 u squared plus c. And so putting back in my u, this is going to be equal to a negative 1/6 cosine squared of 3x all plus c. And which one of those two is correct? Well, they both are. There's a simple identity that'll get you from one to the other. Your program will give you correct on either one of those. But the deal is, you have to understand that if you put the answer in 3 times and get it wrong, and you're putting in a sine, and it's spitting back a cosine, it doesn't mean you're that far off base. You may be off by a sine, like a negative. But it will accept both answers, so just be aware of that.